All right, well, it's good to see everybody again. It's been over 2 weeks since we talked. I know, I haven't seen you since last year. We can actually say that now. So, just a couple things. I was looking at the calendar today. Just want to go ahead and give you a bunch of information before we go ahead and get started. In terms of one of our big ideas, the paper exams, those are coming up on Monday and Tuesday, the 13th and 14th of May. So on Monday, it's going to be at 1 p.m. That's going to be the one with the 15 questions. On Tuesday, 8:15 a.m., that's going to be the one with the 6 questions. That's going to be a little more in depth, but each one of these is going to be 90 minutes. 1.5 hours, so you'll see me on that day. Both myself and Mr. Heinrich have to come and check the calculators and do all that good stuff, but we're going to go ahead and finish everything we have in the class before that. Then, ultimately, I want to go ahead and start reviewing, and I want to go ahead and run you through some practice exams, like some previously released exams, give you like a good hour and a half to actually go through it with the formula book and see, how well we do. Just go ahead and get ready. So we have 17 weeks including this week until we go ahead and take those paper exams. Now remember, together, those are 80% of your IB grade, with the other 20% coming from the IA. Okay, so speaking of the IA, there's kind of good and bad news. The good news is we only have 9 weeks until spring break. Okay. Bad news is there's 9 weeks until your IA is officially due. So it's going to be due much sooner, than the paper exam. So we're going to be taking a lot of time to prepare for that. But I'm hoping in the next month to set aside some time where you guys can go ahead and sign up for specific times, whether in class or outside of class, and we can go ahead and talk about your IA specifically. Did anybody happen to take the break as an opportunity to do anything with the internal assessment? So many hands going up. Okay, but you have 9 weeks left, so I want to, if you kind of emphasize if you have any questions, if you want to talk to me about any of the notes I made, please just let me know. Come on in, and like I said, probably in about 3 or 4 weeks, I'm going to be setting aside some time where you can sign up, where I'll specifically be able to just talk to you one-on-one for probably a good 15 minutes. Okay, so that's coming up. And the other one, I put a question mark by this one because I've given you so much material since the beginning of the school year. I honestly don't remember if I've already given you one of these. Have I printed out a formula book for you? So I have not. Okay, so let me write that down very quickly. So that way, as we get into the review and whatnot, I can go ahead and make sure. Do you want those sooner or later? Sooner? Okay. Formula books. Okay. All right, so I will get those to you hopefully by the end of this week. Of course, it's a short week for you folks because, you didn't come back until today, obviously. But I think that's all I had as far as the class goes. There are a few other items. On Thursday, we are going to have our first quiz. We're going to get right back into it because I know it's been over 2 weeks and you guys were probably muttering to yourselves, I need to do some math. I got to do something. So here we are. We're going to get right back into it. So I know you guys are pretty excited about that. It is super quiet when I said that. Okay, a little too quiet. But the quiz is going to be over arithmetic, sequences, and series. We're going to start geometric today, and it's probably only going to take us a couple of days to get through it, but these are the formulas you might remember from before the break. To find the nth term, u sub n equals u sub 1 plus n minus 1 times d. Remember, d we called the common difference. Okay, that was the value that you added or subtracted over and over again. N was the number of terms. U sub n was the nth term. U sub 1 was the first term. Okay. Now, these other two formulas here, they worked for a series. What was that? All the numbers in the sequence added together. Yes, that's exactly what a series is when you add a specific number of terms in a sequence. So I will be providing you these formulas on the exam. Well, the exam's coming up in 2 weeks, but the quiz, yes. Just like in the formula book, you'll be provided that. So you don't have to worry about memorizing it. It's just one of those things you want to be familiar with. You want to be able to use it. So the quiz is not going to be horrible. The only downside really is that it's over material that's been a little over 2 weeks since we talked about. Okay, so you'll probably want to go ahead and take a little bit of time, maybe at least a good 10, 15 minutes, maybe tonight, tomorrow, go ahead and look over it. If you have any questions, come on in, let me know. And I mentioned this a moment ago. We're still a ways out from it, but I thought I'd go ahead and let you know just so you can plan accordingly. The first exam is going to be on the 24th. So that's 2 weeks from this Thursday, the third week we come back. All right, so I haven't even started putting it together yet, but you can, expect it to have the geometric sequences and series. I'll probably not go ahead and put the arithmetic on there. I'll let you know if I change my mind on that, but it'll have other things. In fact, a lot of the material, I was starting to look over it in the past couple of days, preparing for the second semester, and a lot of the material that we have left is either a review or it's material that you're going to use review material to help you with, like proportions. Okay, remember proportions? That's going to make solving currency problems, converting it from one form to another, very, very easy, and just simple proportions. So really the only thing that we have left that I would expect to be brand new is calculus. I'm going to teach you guys about finding the derivative, but that's going to be the last concept that we talk about. So I'm hoping last year when we finished, we had 3 weeks by the time we finished the curriculum until they were going to take the paper exams, and we spent that time reviewing, going over previous tests. I'm hoping we can, get a little more time this year, but we'll just kind of see, how long it takes us to get through some of the lessons. All right, so that's a lot of information coming your way today. Does anybody have any questions, concerns, comments? Hey, John.
What do the paper tests look like?
What do the paper tests look like?
Yes.
Oh, they're little booklets, and it's just problems. Some of the problems will go from one page to another, depending on if there's a huge graph or something like that along with them. But the first one has 15 questions. The next one has 6. The reason they still give you 90 minutes to work the second one is because even though there's only 6 questions, it could have like A, B, C, D, E, F, G. I mean, it's going to have several different parts. And these parts always combine different ideas. Like the first part, you could be talking about probability, and then you could use that going right into error approximation. So they're just basically giving you some kind of scenario, concept, whatever, and then you're using all these different concepts to answer the questions. But I'm going to give you those booklets. You're going to have the formula booklets as well. I'm going to try to make sure that you feel as comfortable as possible when you see the real thing, so you'll be like, I got this. There you go. Hey, Libby.
Before we start, can you repeat?
Yes.
Thank you.
All right. Anything else? So we're good to go. It's been long enough. We want to do some math?
Yes.
Yay! Okay. All right, well, let's get to it then. Let's see here. Okay, geometric sequences and series. Well, a geometric sequence is a sequence in which each element after the first is obtained by multiplying the previous element by a fixed number, what we call the common ratio. So we're no longer adding and subtracting. This isn't going to be based on a linear function. These are actually going to be much more exponential. Do you guys remember exponential functions? Okay. Okay, like a times b to the x. Do you remember that form? If x is in the power, that's your exponential. We're going to be bringing up a lot of those today. And also, I'm going to be showing you some techniques on the calculator, but also how many people in here remember logarithms? Okay, so we'll be talking about that. I'll be showing you how to do the logarithm itself and also on the calculator. But let's go ahead and get right back to it. So now we're going to be multiplying by a value over and over and over again. Could be a decimal, could be a fractional, could be an integer, but it's always represented by the variable r. That's what we call the common ratio. Remember with arithmetic sequences and series, we had d. So here is the formula. U sub n, the nth term, is equal to U sub 1, the first term, times r to the power of n minus 1, that common ratio. Okay. Now, before, in order to find r, if you were given the sequence, you would just take a term and subtract the previous term. Well, here, because it's based on multiplication, you're going to take a term and divide it by the previous term. That should be consistent every time you divide consecutive terms. Should be giving you the same thing over and over again. If it doesn't, then it's not exponential. It's not going to be a sequence. Okay. Well, let's just get right into it. Let's see what you think. First example, find the 10th term in the sequence 2, 6, 18, 54, 162, and so on. Okay. Well, if I want the 10th term, then I'm looking for u sub 10. Remember, n is the number of terms that we have, and we want the 10th one. What's the first term? 2. Okay, so I'm going to pattern it after this guy right here. So 2 times, and I typically like to go ahead and put the common ratio in parentheses, just because I know it's very closely related to exponentials. You don't have to if you don't want to. In fact, what is r? Yeah, it is 3. Remember, we're going to take consecutive terms like the 6, and I'm going to divide it by the previous term. And the same should apply to every other consecutive pair. 18 divided by 6 is also 3, 54 divided by 18, and over again. So this base is going to be 3. And what's the power here? There you go. So the power would be 10 minus 1 because we know that n is equal to 10. So I'm going to raise that to the 9th power, the 10 minus 1. Yes, ma'am. Oh, just because they're consecutive. I just took a term and I divided it by the previous. Because the idea is, I'm sorry? Say one more time. Oh, yeah, you could have used any of those terms. Basically, what am I going to multiply the current term by to get the next one? So 2 times the 3, the 6 times 3, 54 times 3, and so on. Okay. All right, and let's figure out what this is. I do not have that pulled up anymore. I had to restart my computer before the bell rang. So while that's pulling up, everybody have a good break? Okay. I did. It was kind of rough. You know, my wife was sick for about a week and a half during the break. But, yeah. But, you know, it's one of those things. What are you going to do? Oh, what's up? Okay. La, la, la. Okay, so let's go to A. There we go. So let's see here. We have 2 times, this is not letting me do this. There we go. 3 to the power of 9, correct? Okay, so what is the 10th term? $39,366. There we go. Okay. 39,366. And you know, this one here, it's not very large. Again, it's only the 10th term, so you could multiply by 10 3 times over and over again. Remember, that's one of the strategies I showed you in the calculator. But if it's something like, you know, find the 100th term, definitely you probably want to go ahead and use the formula. You don't want to sit there and multiply by 3 100 times. Okay, well, let's try another one. Find the 11th term in this sequence. Okay, let me give myself a little room here. So we're looking for u sub 11 equals, well, we already know the first term, that's just 1. That's easy enough. What is r? So in order to find r, that common ratio, I'm always going to take a term and divide it by the previous one. Yeah, so negative 1/2 divided by 1 is negative 1/2. Okay. Now, here's the thing. Does anybody want me to go ahead and choose another pair, especially since we're dealing with fractions, just to kind of show that you're still going to get the same thing? You want me to? Okay. Let's see. Michelle, what pair would you like? 1/8 and 1/4. So I should be able to take 1/4 and, oh, what am I doing here? Sorry. 1/8, negative that is, and go ahead and divide it by 1/4. Now, what happens when you divide by a fraction? Yeah, you're multiplying by the reciprocal. So this is negative 1/8 times 4 over 1. So you could multiply straight across and get negative 4/8, or you could simplify on the diagonal, and you'll notice I still get the negative 1/2. Okay, it should be consistent every pair of consecutive values you take. All right. And then let's see here. What power am I going to raise this to? Okay, I'm going to raise it to the 10th. Because remember, the power is always n minus 1, and we're looking for the 11th term. So n is equal to 11. See, it's really similar to what we were doing with the arithmetic sequences and series. We're just multiplying now. Okay, we're dividing to find r, slightly different formula. Okay. So in fact, we could probably just go ahead and leave this as a fraction. Would it be positive or negative? Definitely positive because we have an even power. So the 1 times doesn't change anything. So this is going to be 1 over, what is 2 to the 10th? I'm sorry?
1/5.
Oh, if it's 2/10, yes. But I want 2 to the power of 10. 1024. There we go. So that should be the 11th term. Okay. And does anybody want to see me plug that in the calculator? No? Okay. How are we doing so far? Good? Is it everything you thought it'd be after the 2 weeks? You never know what you have until it's gone, right? Exactly. Hey, look, math. Okay. All right. You can see my humor is still doing its job, so see if I can't step it up a little bit. Geometric sequence has a 5th term of 3 and a 7th term of 0.75. Find the first term, the common ratio, and the 10th term. Okay. So this one's actually similar again to the type of problems that we were looking at with arithmetic sequences and series. Does anybody remember how we solved those? There's a particular word, starts with an S. Well, solution. We want the solution. We are going to be looking at these. It's a review concept at the end of the week. Something of equations. System of equations. That's how I went ahead and solved it. I'm sure that there are other ways that you can go ahead and do so, but that's what I did. Let's go ahead and get the ball rolling. So the 5th term is 3. So I'm going to say u sub 5 is equal to 3. And then we have a 7th term of 0.75. So u sub 7 is equal to 0.75. Now remember, our formula is that u sub n is equal to u sub 1, the first term, times r to the n minus 1, right? We can actually work backwards and figure out what the common ratio is first, because we don't know what the first term is. So I'm going to go ahead and say this is u sub 1, but I can go ahead and say times r to what power? Why to the 4th? Yeah, I remember the power is always n minus 1, right? And for the 5th term, it'd be 5 minus 1. So that's to the 4th. Is everybody okay with how I did that? Can anybody help me out with the other one? What would I set equal to 0.75? U sub 1 times r to the 6th. Okay. So I started off with the term numbers that I had, but I went ahead and used the formula to actually come up with an equation. So let me kind of cut that part off and see, now here's my system. Okay, basically graphically we're going to be looking for the intersection of these two exponentials. But we can go ahead and do something different. I mean, let's go ahead and do it algebraically, because why not? It's been a while since we've done some math, right? Of course. How would I solve this one for u sub 1? What would u sub 1 equal if I solved that first equation for it? Okay, I just divide 3 by r to the 4th, right? So u sub 1 would equal 3 divided by r to the 4th, right? Now I'm going to do the same thing for the other equation. So u sub 1 equals 0.75 over r to the 6th. And what I'm doing is I'm solving this system by substitution. You notice both of these now equal what? U sub 1, so what can I do? Yeah, they can set them equal to each other. We're going to create a proportion. In fact, does anybody remember what property that is? It's of that form, if A equals B, but B equals C, then A equals C. Starts with a T. What? Transitive property, yes, very good. All right. So I'm going to say 3 over r to the 4th is equal to 0.75 over r to the 6th. Okay, why don't you go ahead, take about 30 seconds if you haven't already done so, solve that for me. And there are different ways. I mean, this is a rational equation, so you could multiply through by a common denominator or multiple. You could just go ahead and cross multiply because it is a proportion. And however you would like to go ahead and solve that. And while we have a few seconds, I'm going to go ahead and talk to you about some changes that I did make. Not saying anything against my pre-cal students, but they're great. A lot of them are having trouble over here on the front door trying to figure out what pocket is correct. So if I tell them like Tuesday, they keep going to your Tuesday. So what I did, I'm going to go ahead and keep pre-cal over here on the door. You folks are now going to have this one right here. Okay, just right over here by the broken pencil sharpener. 5 folders in here. Each day is marked Monday through Friday. So, if you're absent and you were not able to get to the website, any extra notes, focus activities, all that good stuff is going to be right there. That way I'm just going to go ahead and try to separate that to help a few of those folks out. Is that good? Okay. Also, being in new seats, that means you have new calculators. Okay, so if you happen to grab your old calculator today, not a problem. Just grab your calculator you're assigned when you come in tomorrow. But also you have new villain buddies. If you look around you, you're going to have new people. Hopefully somebody you don't know, you can make a friend. Okay. Look around. Like John now has Libby and Michelle because you all have purple villains. There you go. So when we go ahead and take time to do that, in fact, take a few seconds, compare your answer with your new villain buddies. See if you're coming up with the same value of R. And if you are, great. If not, then let's see where we went wrong. That's the penguin, yes.
Yay.
Do you know his real name?
The right.
Oh,
Just my sister and my mom are obsessed with Gotham.
I'm very sad it's ending.
Yeah, they're very upset.
My son, he's actually always been pretty upset with me when it comes to Gotham because he's big into comic books, superheroes like I am, but I won't let him watch it.
Yeah, it is pretty.
It is extremely violent and it's got a lot of gore in it too, actually. So while I think they're doing a really good job, I'm like, you can't watch that, son. Cannot do it.
How old is he?
He's 9.
Yeah.
Now, give him a few more years. He's probably seen worse on his own, but I'm still going to try to do the parent thing. All right, so let's go ahead. Let me catch up to you folks. Should I just cross multiply, divide? Would you like me to multiply through to get rid of the fractions? What would you like? All of the above. You actually want to see both? Okay. Let's say first I want to cross multiply and divide. Okay. So this is going to give me 3r to the 6th is equal to 0.75 r to the 4th. Okay. Now the goal is to get r, some version of r by itself. So I'm going to go ahead and divide through by r to the 4th. See, those are going to cancel. Okay, now I'll be able to simplify that in just a second. But since it looks like I'm going to be getting some power with r over here, what's the other value I want to divide by? The 3 or the 0.75? 3. Okay, so what is r to the 6th over r to the 4th? R squared, and this is actually going to equal 0.25. So let me go ahead and say 1/4. Okay. But if you stuck with the decimal, that's fine. Okay. And then how do I get r from r squared? Yeah, square root. Okay. So r is equal to plus or minus 1/2. Now here's the thing. When you're solving algebraically, if you take an even root, a square root, a 4th root, 6th root, and so on, you always want to, it's a good practice, put your plus minus in front of it. But here, it is going to be one of the two. Do you think r is positive or negative here? Okay. Okay, well, we'll come back to that in a second. Let me give you a chance to think about that. Now, the other way, let's say instead of cross multiplying and dividing, I've got the same setup here. 3 over r to the 4th is equal to 0.75 over r to the 6th. I want to go ahead and multiply this equation through by something that's going to remove the fractions. So what could I multiply by? You could multiply by r to the 6th. Okay. Now, r to the 4th isn't going to go into that, but it will simplify nicely. And you can even go larger if you want to. You just have to simplify a little more. So if I were to multiply this, we already saw that r to the 6th over r to the 4th is 3r squared, but the difference is I took care of the other variable at the same time. So now these r to the 6's will cancel, and there's your 0.75. Okay, so you can still go ahead and end up dividing by 3. Okay. Remember, there's always going to be more than one way to do this. Okay. So here, have we made a decision yet? What's the value of r? We know it's 1/2, but are we going to say positive or negative? And is it possible to have two different sequences with one positive and one negative? Yes. Now, IB doesn't go that far, so basically we just have to figure out which one we're going to take. What do you think, positive or negative? Oh, I'm hearing a little reaction. How many people think positive?
I'll go with
Oh, I thought I heard way more people saying positive. How many people are going to be negative? Okay. Well, think about these terms here. We got the 5th term and the 7th term. So those are what? What numbered terms? They're odd, right? Okay, there you go. All right, so we have to go with positive. So r is equal to positive 1/2. Okay. Now, I believe in this problem, it actually doesn't matter because you're going to go ahead and end up raising it to an even power anyway, but, just in case. All right, so is everybody okay with how we got 1/2? Sydney, are you okay with how we got 1/2? Oh, that was my question. Oh, you're fine. Okay. Now, would you like to try the rest of the problem on your own? We still got to find what? We found r. So you want to find the 1st term and the 10th term. Okay, so would you like to continue working this together, or do you want to go ahead and try a few seconds on your own? Try a few seconds on your own. Okay. Whoever it was out there said try a few seconds on your own, because I get it. It's been a while since you've done math. You want to try it, by yourself. I get it. Okay. There you go. And then if you feel confident with your 1st term, go ahead and use that to find your 10th term. I believe that's the one it wants, right? Yes. Okay, does anybody believe they have the 1st term and they want to go ahead and share it? Okay, Spencer, what do you think? 48 is right. How many people got that? Well, I'm just wondering, why didn't you guys raise your hand when I asked about the 1st term? You got to have confidence. Let's talk about it. You'll notice what I did here. I've got 2 equations to choose from, so I can plug that value of r into either one of them. Let's say the first one. So 3 is equal to the 1st term times, we know now r is 1/2 to the 4th. Okay, and then you're just solving in an equation. What is 1/2 to the 4th power? Okay, that is 1/16. 1 to the 4th divided by 2 to the 4th, right? Now I could go ahead and divide through by 1/16, or I can multiply both sides by the reciprocal, right? Okay, and the 16 times 3 is where I get that 48 from. Yes. Okay. Now I have everything I need. All I got to do is plug in. I should be able to find the 10th term. So u sub 10 is equal to the first 48 times 1/2 to what power? 9. Okay. And this one, I think I'll just go ahead and type it in. Let's see here. 48 parentheses. I'm just going to go ahead and put in 0.5 instead of the 1/2 to the power of 9. So what should I get when I push enter? Okay. 0.09375. Okay. Anybody keep it as a fraction? Okay. 3/32. There you go. Let's go ahead and plug that in. If I took 3 divided by 32, okay, that's exactly right. 3/32 or the decimal. Either's perfectly fine. I'm probably going to go with the fraction just because it's easier and quicker to write. Okay, how many people got that right? Good, good, good. Does anybody have any questions? Anybody having a hard time with geometric sequences and series? Okay. All right, let's try another one. Find the number of terms in the sequence, 0.25, 0.75, 2.25, all the way to 44,286.75. Okay, so what variable am I actually looking for? The number of terms, so that would be n. Okay. So I need to know the number of terms going from the 0.25 all the way to the 44,000. Okay, now this one does have the log concept to it because you're looking for the power. Is this one you would like to work together or try it on your own first? How long has it been since some of you looked at logarithms? I don't know. I don't want this problem to stump you. Log stump. Okay. I'll tell you what, if you guys are ready, we'll just log on. It's been over 2 weeks, man. I got to get something out. My kids are tired of hearing my jokes. So okay. So can anybody tell me I need the expression or the equation, let's say. Okay. So we don't know the number of terms, so I got to start, U sub n. Okay. Or actually, no. I'm going to go ahead and let you guys tell me. Yeah. You guys tell me what the equation is going to be to help me solve this. Let me go ahead and write out the normal form like I was about to. U sub n is equal to U sub 1 times r to the n minus 1. Now remember, we're looking for n. Okay, well, do we know the first term? Yes. Okay, so that's one we already know. So we do know the first term. Can we easily figure out the common ratio? Yes. Okay, in fact, let's go ahead and do that. What is it? Yeah, it's just 3. So r is going to be a term divided by the previous term. Remember, because you're multiplying in order to get the next term. So that's just 3. So 2.25 divided by 0.75, again, should give you 3. Now, if you ever come across a problem and it doesn't tell you arithmetic or geometric, all you're looking for is one value that you add or subtract over and over again, or you multiply just to be able to tell the difference. Okay. Now, we don't know n, but we do know what? We do know U sub n. We know the nth term. So what am I going to put here? Okay, so 44,286.75 equals. Okay, first one is 0.25 times 3 to the n minus 1. There we go. And see, this is what makes it logarithmic, because we need to figure a way to pull that variable out of the power and mainstream it with the rest of the equation so that we can solve for it. Does anybody remember that? Like, what are the 3 parts of an exponential or a logarithm? We got the base, okay? So the portion that carries, and I'll go ahead and include that even though it's a scale factor, but this one right here will be considered the base. Then we have the power, so this would be the what? Starts with an A. The what? The answer? No. Good. That's a good word, but not the one I'm looking for. Okay. When we're dealing with logarithms, we call it the, if I can write to that, that'd be great, argument. There's always 3 parts to an exponential and a logarithm because they are what to each other? They're inverses. Okay. And what is a logarithm? If you could sum it up in one word. Starts with a P or an E, depending on how you want to define it. Is there a P word up here? Power, but we also can call that a exponent. That's what a logarithm is. It's the power you place on the base in order to get the argument. So if I were to take this and rewrite it as a log equation so that I could solve it, this would be log of what base? Okay, base 3, all right, equals. Now you'll notice I'm forgetting something. We'll get to that in just a second. Log base 3 of, what's my argument? There you go, 286.75 over the 0.25, and that equals n minus 1. You guys remember that? Okay. You want me to give you just like a one over to the side, just kind of for reference? Let me give you an easy one. We were looking at one just a second ago. We had 2 to the 10th. This has nothing to do with this problem. I'm just giving you a little side example, FYI. Remember, 2 to the 10th was 1,024, right? Okay. So if I wanted to go ahead and write this as a log expression, I could go ahead and say log base 2 of 1,024 equals 10. Because once a logarithm, it's always the power you place on the base in order to get the argument. You guys kind of remember that? And that's why here, I really should have shown the step, but I just kind of went through it. The base is just 3 because that's the only one holding the power. We would just have to divide that over before we converted it. Okay, I just kind of didn't show that step. All right. Okay, is it starting to come back? Okay. Don't worry, logarithms, their bark is worse than their bite. If you're having trouble with logarithms, just stick with it. Tree jokes. Okay. At this point, I feel I should just leave it alone. Okay. All right. Well, what do I do now? How would I solve for n? Okay. Yeah, we're just trying to solve for this variable, so all I would do is just like any other equation, I just isolate it. So I want to take this expression and add 1 to it. Now you can just go ahead and type the entire expression into your calculator. If we come on over here, okay, now where do I find the log? Yeah, in fact, let me get rid of all this right here. Control B. So if I hit Control and then 10 to the X, that's your log button. And you'll notice on the TI Inspire, it gives you a base for the X in your argument. So this was base 3 to the power of, we had a fraction here. What was it? 44,000 what? 0.75. And then we were going to divide that by 0.25. Okay. And then I want to get out of there. And then we were going to add 1. Okay, then I'm going to go ahead and push enter, 12. That 44,000 should be the 12th term. Okay. Now there are a few other times, you know, when we go through these, the logarithms are going to go ahead and come up. And if you're familiar with them, if you feel comfortable, great, fantastic. There is something you can do if you don't remember logarithms or you are having a problem. Let's say you still need to solve this, right? Okay, if you were to come over here, because remember, what can you use on both paper exams? Your calculator, okay? So if you were to go to menu, 3, numerical solve, you can just type the entire equation in there. The only thing is I'm going to change n to what? X. So we had, what was it? One more time, 44,286.75. Now, this equaled, was it 0.25 times 3 to the n minus 1? Okay, so the equals button is right over here below control. Equals 0.25, and I'm going to go ahead and put this in parentheses, 3 to the power of x minus 1. Okay, now here's the only thing you have to do, or does anybody know when you're using numerical solve? There you go. Whatever equation you put in, you have to identify for the calculator what it is it's solving for. So you have to put comma, and in this case, x. And comma is way down here at the bottom left. So just comma x. So you just type it in. As soon as you push enter, boom. Okay. And as we get, a lot of those things I haven't shown you yet, you're probably aware of on the Inspire, but I'm going to make that part of the review as we get closer to the paper exams. Because you can use a calculator, so definitely use it. Okay, especially with 90 minutes, for example, and 15 problems to do. All right, questions. Okay, what time do we got? 2:05. Man, time flies when you're having fun. All right, so we'll go ahead and stop there. Tomorrow we'll come on in. We will hopefully wrap this up. We don't have a whole lot left. It may take us a little bit into Thursday, but definitely by Friday, I'm thinking we should be starting systems and quadratics. Okay. Oh, also, while I'm thinking about it, part of the quadratics review is a bunch of factoring, specifically a trinomial. I have a little factoring map that I've given my students in the past. Would you guys like me to print some of those up for you as a review, or you think you'll be okay?
Yes.
Yes, please. Okay, let me write that down too.